Hello everyone and welcome back to Python Full Course Part 20, and today we're going to look at generators as well as the yield keyword. So let's get started. As always, we're going to create our directory, create our file, main.py inside, and now we're going to start coding. So I'm just going to do a generator and I will explain how it works. So let's say I wanted something that generates a range of numbers from 1 to a certain number. So what I'm going to do is that I'm just going to say define generate range up to a number n, and I'm just going to say counter is equal to 1, and what I will do is that I will say while counter is smaller equal than n, then I want to give that number that I currently have to the generator, so to the one that wants the generator, so yield counter. And what I will do is that I have to update counter now, so counter plus equal 1. Now if I say for I in generate range up till 25, print I open up a terminal, I activate my conda environment and I run it, then we now see that it's going to start printing from 1 up till 25. So what the hell happened? What happened is that you have a function that's just going to run code, and at any moment in the code you can use a keyword called yield. Then what you want to do is that you put yield, and besides it you have to put a value or an expression. So you want to yield and value, so yield counter in this case. Then it's going to say to the for loop, for I in generate range 25, I want to get the next time you say yield. So at first it's going to say when is the first time you're going to say yield, and then it's going to keep running until it says this, so yield counter. Then it's going to give 1 to I and then print 1. After that, it's going to request, give me the next yield statement. So it's going to keep running, and then it will stop here again, but counter is equal to 2. Then counter will give here, I is equal to 2, and then we'll print 2. Then the for loop will again ask, give me the next value. So now it will go counter is equal to 2, yield that, and what it's going to do is it's going to yield 3. Now I becomes 3, and now it's going to print 3, and so on. That was one way to use generators in a for loop, and that's what you're going to mostly use it. Another way is that you can have value is equal next, and then you just need to put the thing you're going to want to, so generate range 15. So first you're going to say iterator is equal to this, and now you just want to do next of that. Now you print the value of it, and now you'll see that we get 1. Then I can say next value is equal to next of iterator, and I can print next value. We now see next value is going to be 2. We can repeat that again, so I can say print next iterator. And I can do this a lot of times, so be prepared to see some Vim magic. Paste it, and then let's do, 50 paste, and now bam, everything is pasted. Beautiful. Now Python main.py, and now you see it gets up till 15, but then I get this weird error says stop iteration, and everything that stop iteration. And stop iteration means that there's no more yield statements. I cannot give you any more value. You've stripped everything I've ever had. So the function is like, don't take any way away from me. I no longer have any yield statement. Everything's kaput. Everything's finished. And so it raises an error to tell the whole code to say, mayhem. Now this guy doesn't have a value to yield. How do we handle this? Well, I'm just going to delete this ridiculous chunk of code, and now let's just write a for loop. So all I'm going to say is while true, next iterator. Next iterator. We should get the exact same behavior, so stop iteration. We just need to wrap it in a try except. So try this, and then accept whatever except stop iteration. Now I just need to say print finished iteration, and then I can break from the loop. Break. And now you'll see it's going to work. So 1, 2, 3, 4, 5, 6, 7, up till 15, and then finished iteration. Notice that you can also do a more simplistic way of doing a generator. So you can say define generate names, and then doesn't take any inputs. So I'm going to yield James, yield Bob, and then yield Fido. And this is going to work as well. So iterator equals generate names, and now I'm going to do the same thing, and now as you can see it's James, Bob, Fido, finish iteration. So you just need to put yield anywhere in the code, anywhere in the function, and then it's just going to keep asking for the next thing. An interesting thing about generators, however, is that when you don't want to get the next value anymore, it will not run the code. So you can just say print this code will not be run, and then here I can say print this code will be run. So I'm just going to do next iterator just 3 times, and we'll see that first both of them are going to be printed, but if I remove the last one, then now this code doesn't even get run at all. So if you don't want to request for the next element in the generator, then the code will not run. So this is very, very, very fun because it allows you to only demand data on demand. So all you need to do is that you can just say a infinite loop. So I can just say yield yo, and this is going to yield yo infinitely times. If this was a real function, then it would just start creating a list of lots of yo 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 all that up till it crashes your memory. But since this is a generator, it's only going to give it when you want it. So define generate yos. This I changed to generate yos. And now you see that nothing's happening, everything's working. So I can just print. No, I'll just print it here. Print next. And now you see next. And as you can see, there's not any infinite loop. So this is the advantage of having generators. It allows you to have an iterator that has an infinite size. So for example, you could have the list of natural numbers represented in an iterator, and then what you could do is that you could use the primes sieve to generate prime numbers. And the most elegant way to do this is that you use Haskell, because by default, every list is kind of like an iterator. So it is lazy. So well, if you don't demand the next element, then it's not going to calculate it. And that's why Haskell is a beautiful language, and I'm planning to make tutorials on it. So anyways, that was a bit off topic, and that was all about generators. In summary, you just use the yield keyword to return an expression, and then this is what's going to return when you call next of that. However, when there's nothing to yield anymore, it's going to make an error called the stop iteration, and in that case, you have to handle it yourself. However, if you use a for loop, then it's automatically handled for you and it's just going to iterate over the generator. And so, that was all. Thank you for watching. If you like this content, like, subscribe, do all that good stuff. And in the next video, we're going to look at the request package. So stay tuned.